Hello, today we're having a session for creating a mechanism for VAR mechanism with a slider. The purpose of this session is how to use the motion simulation module of an X besides using the modeling module for creating the dynamic diagram of the mechanism, which is called skeleton. And we're going to start with the next creating this mechanism. Very important is once you select new mechanism, you make sure you are on modeling module, because in some cases will be on drawing or some other of the modules, but you have to start with model. Okay, and also very important to select the units. In this case we're going to be using millimeters model, and let's select a folder of the one you're going to be using on the future ends. Is the way to easier find your files once you create all of them to be saved on one folder. In my case, I'm typing 01 motion simulations. Okay, then double click on it. This is my directory. You're going to type 01 underscore 4var mechanism. Okay, and then select OK. Once you're here on this screen, you need to go to Sketch and select the XZ plane. You can see here it's selecting the XY plane. We don't need that one. We move our selector on the, excuse me, is the XZ plane. So select the XZ plane. And once we have the golden axis, it's okay. Very important, go to more. In the case you have the continuous auto dimensioning selected to unselected, it's a good practice to unselect continuous auto dimensioning, or you can do it from previous definitions. I'm going to show you in some other videos how to do it. Okay, so right now let me show you how to create a forward mechanism. It's important that you have the information first of all to create a mechanism. So in this case, this is a forward we did during class last time. So we have the links number 1, 2, and 3, and the 4 for this variable. So we have the constants L1, which is 75 millimeters, L2 is 250 millimeters, L3 is 350 millimeters. Okay, so let's go to profile and create this. See, avoid this icon that creates a perpendicular relation between these two lines. We need only these two lines, and then this line, and then this vertical, and then this horizontal. Escape, escape. Click on these three lines and convert them to reference. Okay. Then let's go to rapid dimension and select the link number 2. Make sure you have this option. I think link number 2 is 250. 250. Excuse me. Let's move a little bit. So you can see it moved upwards. So you click on this line, drag it down with your left click, and then you put it like this one, and this one drag it to your right with your left button, Rapid dimension, this one is 75. And this one is 350. Scale. We're going to start with a 40 degrees theta 2. Okay. Rapid dimension, let's go to angular dimension here, and that's 40 degrees. Okay. Escape. Okay. We have all the model here. And that's a really good way to see the value of the L4, even though this one it's already full defined. Let me show you this. I mean, I should go to reference dimension, but in the case you forgot to do it and click on this line, everything will be in red because it means it's over-defined. So what we have to do is just Ctrl Z, once again dimensioning, reference dimension, and select this horizontal line, closed. Okay. I really recommend once you go to this dimension, just make sure you don't continue having the dimensions on reference option, because this is only for moving all my mechanism. In this case, you want to see what happens with some other values. For example, let's change it to 30 theta 2, and we should have 503.7 for L4. So let me double click 30 degrees, and we have 503.7 like in the Excel file. Okay, let's change it again to 40 degrees. That's it. Now let's create several circles that will be helping us to create a center of gravity and to create all the joints we need to use for all the mechanism. In the 0, 0, we create one circle, and the midpoint, you see, once I move the selector over the line, it's showing me a predefined point or dot. That means I am on the midpoint. In the case you wait a little bit, you will see that 3 points appear, and then you left click, and it helps you to select midpoint also. This is point on curve or midpoint. You need midpoint. Okay, and then they create a circle, then another circle, then on the midpoint another circle, and then another circle. Okay. The value of the circle will be, let me see, 30. I mean the diameter of the circle before, and I need all of the circles to have the same measure, so I dimension all of them with a P for reference. Before, 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 closed. Okay. And then we need to create a rectangle. This one has to have the option of from center as a method of creation. It means we're going to create the center of the rectangle, then a midpoint on your right vertical line, and then the end point of the same line. So click here, and then to your right, and then upwards. Escape, and let's create this first dimension, which is gonna be, let me see, 40, 40, and 60. Okay. Now let's finish the sketch and then go to the option of motion simulation. I need you to be practicing very much with this module, motion simulation. It says the master model part 5 has been modified, so you want to say the changes, okay? Yes. And then in the dialog box of the motion navigator, you create a new case of simulation. It's going to be called 1_motion. And then you type OK. Okay. Well, let's start working with the links. Let's create 4 links. You select this, and this circle, and then this line. So the first link will have 4 entities here. And then in the case you don't have this dialog box with the mass and inertia, it means maybe you have to expand it from this black arrow to see the mass properties option. So you go to the center of mass. You must have this icon selected, center of mass, and center of inertia. It's important that you have this icon also selected, which says coordinate system of the object. And I really suggest you to have these values: 1 kilogram for the mass, 2, 2, and 2 for the parallel inertias, and 1, 1, 1 for the orthogonal inertias. And you type C1_crank. All the links have the actuator or motor connected to it will be called cranks. You apply. Then the second link, click here, here, here. We have 3 objects selected for this second link. Center of mass is the center. Center of inertia of the system here also. And then once again 1, 2, 2, and 2, 1, 1, 1. Okay. So we're going to type CO2_follower as the second name of our links. Click apply. And then our last link that will have these 4 entities. Select this and this and this. You can see here we have 4 objects. Then center of mass, this circle, center of inertia. You see it changes immediately. Select this circle and the same values: 1, 2, 2, and 2, 1, 1, 1, 1. CO3 slider. And you select OK. This is the last of the links. You expand these options. Okay, crank, follower, and slider. Joints. Let's go to Revolute. You select this circle. This circle has the direction on the negative side, pointing out to the negative side of Y. So we have to change it, okay, with this icon, reverse direction. Okay. And then display scale 3. Okay, remember Revolutes, they have a very small icon, so we have to increase the scale. C1_revolute or rev, and then crank. Apply. And then let's create a second joint. This one will be an slider, and the slider, it's part of this link. Okay, you see that the vector it's pointing out to the z, positive z, and we have the center of the coordinate systems here. So we have to select a circle to define the origin. Click on the circle, and the vector it's using this line. Okay, display scale could be 1 because in the case of the slider it's big enough. 02 SLD from the joint, and slider for the name of the joint. Apply. Okay. Then let's go to create another link. This one will be here. Change to revolute. This is the revolutes here, but remember to change it to the positive direction. It's just like a discipline of the sign. Everything putting in the same direction. Could be everything in negative or everything in positive. Okay, display scale 3 and 03 revolute follower, excuse me, it's crank follower. Apply. And here you see that we have a similar icon like this one. Okay, it's a revolute. It has ground symbol here. It means that we need to do something else because it shows an independent link. So you expand the joint, double click on the last joint, which is this one, and go to base, select link. Please don't select snap links because it will make rigid the revolute. Select link, click on this link, set OK. Now the ground symbol, the ground icon is left. It means this is an dependent joint, and here we have an independent joint. Okay. Let me create now another dependent link, which is in between two links. Go once again to joint, revolute. Select link is this one. Make the vector positive. Select link, and you touch any of the lines that belong to the slider. Okay, display scale 3. You're going to type, in this case, 04 underscore revolute, and in this case, it's follower slider. Okay, follower slider. Okay. We have our 3 links, our 4 joints. Then you're gonna double click on revolute crank, and it's important that you see on this dialog box you have definition. Go to driver and select constant, which is a constant velocity in this case. You change the units to revolutions per second. You're going to type 1 revolution per second. You set it OK. And then let's go to create a case of solution. Go to motion, which is one case of motion. Right click, new solution. Then we're going to type 2 seconds and 100 steps. It means the number of steps is the number of pictures the NX takes for every period of time we give. In this case, we're giving 2 seconds as a period of time. So it is taking 50 pictures every second. The only reason I'm having these steps is to make the motion more accurate or the simulation more accurate. But it reduces the velocity once you increase the number of steps. When you have very few steps, the motion is quite quickly, but it's in some cases kind of difficult to see all the motion. And if you have a lot of steps, it's really easy to see all the motion, but it's very slow. Okay, and once you create a video, it's going to be quite big. Select solve with OK. C1 solution and OK. You will see computers always creating redundant constraints that they detect, so it's deleting of, it's removing all these redundants. Close this dialog box. Animation, animation, and then make sure you have this on loop. Let's go to a from view. Okay, and then type play. Okay, you have all the motion here. Okay. Okay. Now we would like to see the displacement, velocity, and acceleration for this mechanism. So first of all, we have to go to layout, layout settings. Okay. In results, we checked for views. In area of the view, we have a different graph. So we go to graphing, expand, left click, right click, new, and we select the part of the mechanism that is that shows the important information we need. In this case, the slider is the one that has this information. You can see that there is a big orange sphere that shows us what's the point of interest, and then we go to displacement, add one curve, C1 underscore displacement, and then select apply. It is asking me for the viewport you see here. So you select this viewport. Then once again the same slider, different request, in this case is velocity. The component is x because in the x-axis is the motion we care about. Okay, so let's add one curve, in this case CO2 velocity, apply, select the viewport, and then for the slider, once again, go to acceleration, once again, x component, add one curve at 0.3, acceleration, apply, and select this viewport. Okay, cancel for the graph generation, and let's go once again to home, animation, animation, and let's delay here. Let's play. You can zoom a little bit here. You see all the motion. Let's go to pause, and you see how we have the mechanism here. Here we have a almost maximum. See, it doesn't have exactly maximum because it needs more steps. But anyways, it's almost maximum. And then the displacement is maximum position. Okay. The velocity it's coming from positive to negative because it will start to move on the negative side of the x. Okay. And the acceleration will start to increase. Okay. Okay, because the delta of the velocity will be increasing. And then you see it is moving to my left. Okay. You see it's decreasing, decreasing, decreasing. And then in the minimum value of the displacement, okay, you see the velocity starts to change from negative to positive because the slider will start to move from a motion to my left and it's going now to my right. So it changes, you see, it changes from negative to positive. Okay, and then it stops here. Okay, when it stops, the velocity is zero. It's changing from positive to negative, so it's zero. And this is in maximum, almost in maximum position, and on and on and on. Okay, we have maximum acceleration here. You see, it has a peak of acceleration here, and then it starts to reduce. Okay, that's the way to create our mechanism and to create anything we need for the information we need to have from displacement, velocity, and acceleration. Okay. Okay. Guys, thank you very much. See you during class. I hope it is helpful. I need you to practice this very much because we're going to have a lot of exercises related to motion simulation. Thank you very much.